So hello and welcome back to another day and another lab session in ROS. Today I will go over the basics of ROS file system and understanding what is a ROS workspace. This is again related to the lecture that you all should have seen by now, which was posted earlier this week. I hope you've booted up your virtual machine instances or dual boot or what have you. And then we can jump right into learning more about how does ROS organize its workspace, what is the build process, and in general, what is the workflow when you work with ROS packages, because this will have to become your second nature when you work in ROS. So let's jump into it. And the first thing we will start is we will create our first workspace, right? So we covered this in our lecture, how this is done using some specific commands, but I'm going to show you and you can follow along with me. So the first thing we are going to do is we are going to create a new directory where we want our workspace to reside. So let me just do that. I'm going to create a directory and I'm going to create it in my home directory. That's what the tilde is for. And then I'm going to just call my directory catkin underscore workspace. And in fact, I'm going to also create a subdirectory called source. And in fact, if you're not sure what is going on, this argument -p is essentially telling Linux that when you create this directory source, if the parent directory does not exist, you also create the parent, right? So we are creating multiple directories at the same time. So that was it. And then we can change to the directory that we just created. So we can go navigate into source. And there you go, it exists already. And to create, so this is just a regular directory right now, right? So it has nothing to do with the ROS installation on this machine. But to assign this as a ROS workspace, all I have to do is run the command catkin underscore initialize workspace. And as you can see, if you hit tab, it should autocomplete for you. And so when we run this command, it echoes that it is creating some symbolic link between the CMake file in our source that we just created, and it's pointing that to where ROS is installed on the machine, particularly in some relevant subdirectory in the Catkin build system, right? So the CMake file is getting kind of symbolically linked to some top level CMake file which exists on your system where ROS is installed. So what has that done for us is we have now initialized this catkin underscore ws directory as a catkin workspace, but we're not quite done yet. What we have to do is we have to navigate to the root folder itself. So earlier we were in the source subdirectory, and from this root folder of catkin underscore workspace, we have to run the command catkin underscore make to finish this process. And so it'll take a second or two, and it's already finished. And you can, go over trying to understand all these different outputs that it echoes when you run the make process. But essentially, it is what is happening underneath the hood is that now our Catkin workspace, if I just clear the terminal, now the Catkin workspace is no longer just an ordinary folder on your machine. Because we initialized this as a workspace and we ran catkin make, it is now a ROS workspace, right? So what that means is already, if we look at the contents of this directory, you will see we had only created the source folder, but upon running the catkin make command, essentially running it for the first time, it creates this CMake list in the source folder that we saw. And also additionally, we are looking at the current directory. We see that we have a build folder and also a development folder. And in fact, if we go inside the development or the devel folder, we can say we'll see with there a lot of these setup.sh files. So let's quickly let me quickly show you that. If I go into development folder and list the contexts, we see a lot of these files, setup.bash, setup.sh. And so this becomes important. These files in particular are are of importance, because what we will do is whenever you run, let me quickly go back to the root itself. Whenever you run the Catkin make, it's good practice to source your environment, right? So you can say something like source Catkin workspace, the development folder, and we will source the file setup.bash. And essentially what this is doing is it is telling the bash terminal that Catkin workspace is a ROS workspace, and this is the path to that ROS workspace. And this will become important in a second, because in order to use a lot of the file system tools that ROS provides, it needs to know where things are located. That's how the tools are going to work. And sourcing your setup.bash for your custom workspace is telling this terminal instance or this bash system where things are located, and you'll see how useful that will become in just a second. Okay, so we just created our first ROS workspace, and right now this workspace is not doing anything in particularly useful, so we can go into the source subdirectory, and there is just a CMake file which was created as part of the initialization process. There is no source code or custom messages. So you know, all your packages for this workspace are going to reside in this source subdirectory, and currently it's empty, okay, because we haven't really pushed any code or written any nodes yet. So this was just a very quick walkthrough of how do you take a normal directory, and you don't have to call it Catkin workspace, as that's just like the I think conventional ROS tutorial nomenclature. You can call it whatever you want as long as it's a valid directory name. Okay, so let me clear all of that and also navigate back to home. Okay, so now I want to just quickly walk you through some essential file system tools. And these are tools that are command line tools, most of them, and we'll cover maybe 2 or 3 of them today. And they will be, save you a lot of time. They will be a very efficient way to navigate across large ROS projects. And you'll see in a bit what I mean by that. So in order to follow along, what you should first ensure is that you have a particular package called ROS tutorials installed in your distribution. And a quick, easy way to do that is just try to reinstall it. And let's say we will go sudo apt get install, and the name of the package should be ROS melodic. If you're not using melodic, just replace it with the correct name, kinetic or noetic. And then the package name is ROS tutorials. Right, so we will attempt to install that. And as you can see, in most cases, it should already be installed. So nothing was actually installed when I ran that, because I already have ROS tutorial installed. And we are using ROS tutorials just as a way to understand the ROS file system tools. So what are these file system tools? Let me talk about the first tool, which is called ROSpack. ROSpack is a command that will help you inspect packages, right? So far we have learned ROS node, ROS topic, ROS message to interact with nodes, topics, and messages, but we haven't really looked at, how do you interact with packages, or how do you, from the command line itself, inspect what are the dependencies of the package, or even as something as simple as where the package is located. So because we installed ROS tutorials, some packages are already present in your distribution. And so the first command we will look at is ROSpack find and the name of the package. So for example, we know a popular package is the ROS C++ API. And so I can just say ROSpack find ROS CPP, and it should tell me where is this package located on my machine, right? So without having to worry about figuring it out on my own and doing some grep or ls kind of mechanism, if you know the name of the package, it will tell you where that package is. So what's another package that we all know of? Of course, it's called TurtleSim. So why don't we say can you tell us where is total sim? And sure enough, if you recall from the lecture and even from the previous lab session, total sim is installed in this melodic share total sim directory itself. So another use of ROSpack, let's quickly clear it. Another use of ROSpack is a command called depends. So we can say ROSpack depends, and I want to check, what are the different other packages on which total sim depends. And so when I say that, ROS automatically tells me that the total sim package itself depends on all of these other packages, and at least a few of them you may recall from our discussion in the lectures and the previous session. So definitely, geometry messages should ring a bell, because that's what the total uses to publish pose and command velocity and things like that. Then it naturally also depends upon the C++ library and many other messages, of course. So that in a nutshell is the use of ROSpack. And like with any ROS command, we can always say something like ROSpack help, and it will tell me what are the different arguments that ROSpack accepts, right? So we just saw two of them. We essentially saw ROSpack find and ROSpack depends, but there's many others as well that you can play around with. So this is in general a very useful command to navigate the ROS file system. So similar to that, we have our next ROS file system command, which is called ROScd, or ROS change directory. So this is the ROS equivalent of change directory. And here, I can say again, I want to change my current working directory, which is my home directory right now, to where ROS CPP is located. So remember, ROSpack just told me where this package is located, but now when I run ROScd followed by the name of the package, it has changed my current directory to where this package was located in my system. So this is very useful because as we create our packages, we may want to navigate to the source folder of that package to make changes to some Python script or some ROS node. So you don't have to specify the entire path always, and so it saves a lot of time because you can just say change directory followed by the name of the package, and it works. It doesn't matter what is your current directory, it will work from there. So I can again say ROScd, and then I want to now go to keep misspelling total. I want to now navigate to total spin. So now it has automatically changed my current working directory to total sim. And I can, if I was at my home, I can again could have said, now that I know that total sim has these subfolders, so I could have said, even I can navigate to a specific folder. So let's say I want to navigate to images. Within total sim, it will navigate me to that subfolder. And if you recall, images is where all the actual image files of the total are stored in the system. Okay, so this is again a very useful command called ROScd. It will save you a lot of time and something to remember as you navigate through your assignments and projects, which are coming soon over the next couple of weeks. Another thing you may want to try out is the use of this command ROScd and followed by, let's say, log. So remember how I said when you launch ROS core, some logging nodes are automatically launched in the background. And so to get to where those log files are, you can do ROSpack find as well, but you can just simply say ROScd log. When you run it right now, it will not run because it says correctly there is no log file because we aren't running any ROS core or any other nodes per se. So ROS is not running, right? We are just simply navigating the file system. So I should have specified that to use all these command line tools, you don't need to run ROS core. Okay, ROS core is a prerequisite when you want to start launching nodes and things like that. So we have ROSpack, we have ROScd. The next command is also very useful. it did actually navigate to where the log file was. It's just that that folder had no contents because we aren't running anything yet. So natural extension or another variant of another useful ROS command is what is called ROS-ls. Right, so this is the ROS equivalent of ROS plus ls, or the listing of the contents of a certain directory. So I can say again ROS-ls, let's say ROS C++, and the package could be there's another package called C++ tutorials, which is installed in this ROS tutorial thing that we just downloaded a couple of minutes ago. So the difference here is that my current working directory has not changed. I'm still in my home, as you can also see here, but I can inspect the contents of a package or list exactly the contents of the package without changing my home directory. So that's how it's different from ROS-cd, right? So I can also try, let's try again with total sim and images, and it will just tell me what are the contents of the images subfolder of total sim, exactly what we saw a second ago, but this time it's telling me that without changing the current working directory, right? So it's a very useful feature accompanying these other two commands of ROSPAC and ROS-cd. So in a nutshell, you have, if you haven't already done so, but you've noticed the pattern with the naming of many of these ROS tools. Essentially, ROS-cd is ROS plus change directory, ROS-ls is ROS plus ls, ROSPAC is ROS plus, the package tool in Linux itself. So this naming pattern holds true for many other ROS tools as well, and we may discover a few more useful ones down the line. But for the time being, the three that I mentioned right now already are going to be very, very useful. Okay, so let's get back to the original thing that we started before we took this tangent into ROS file system. So just a second ago, we created a folder called Catkin workspace, and we know this is a ROS workspace. So we did this initialize workspace and Catkin make process. Now we will create our very first package. Okay, so this workspace doesn't have any packages yet. This is just a ROS workspace. So remember from the lecture that packages usually reside inside ROS workspaces, and so a trivial workspace looks something like there's the root workspace folder, which in this case is catkin_ws. It has a source subdirectory which also exists, and inside the source subdirectory we have package 1, package 2, and so on. And then if you also remember, each package has its own package manifest.xml, so package.xml, which is the manifest file for that package, and each package also has its own cmakelist.txt file to give the input argument to the Catkin build system and on how to compile the code in the package. So since we've already created this directory, we will actually navigate to the source subfolder, and this is where we will create our very first package, and we will use this command called catkin create package. Then we have to provide the name of our package. Let's call it beginner tutorials, and then I can provide the dependencies of that package. So I'm basically telling Catkin what other packages are needed for beginner tutorials to be built, to be run, so on and so forth. So if you follow along, we can provide 3 dependencies. So first one is what is called standard messages, so std_msgs. Then we hit a space. We want access to the ROS Python API, and we want access to the ROS C++ API. So I'm specifying 3 dependencies. I can continue, I can say geometry messages, and all of these other things that we have seen in, say, TurtleSim as well. But since this is just a basic example of how to create a package, I'm just going to go ahead and run this. And so you can see when I run Catkin create with these dependencies, let's actually look at the output here. It says that it has created this file called package.xml as part of this directory beginner tutorial. So not only has it created the directory, which is the name of our package inside the source folder, it has also created a package manifest. It has created a cmake list.txt file, and it has created the structure of the package directory itself. So the package directory also has its own source file. So we are not quite done yet, because remember what I just told you a second ago, that whenever you change anything in the workspace or in a package, you need to build it first before it is becoming a part of the workspace and you can use that package. So just to recall, the build process is you always navigate to the root of your workspace, which is the Catkin workspace folder in our case, and then we can run Catkin make. And as we run Catkin make, you will see it is taking some time to build this beginner tutorial package that we have. So just so that you know that the beginner tutorial package does not have any code yet. We just created a directory and specified the dependencies of that package on other packages. Also make it a habit that when you do run this Catkin make, it's always a good idea to source your file, to source your setup.bash file, which is part of the development folder. And I'll explain why we do this sourcing. In fact, let me explain that right now by opening another instance of the terminal. So we have just created, and we did a Catkin make on a package, and let's quickly get familiar with what has happened. In our workspace, we already had these three folders: the build, devel, and source. Now inside source, we have this new folder, which is called beginner tutorials, where it has been created by ROS itself as a result of running this Catkin create package command. So inside beginner tutorials, we have all these directories and the manifest and the cmake file, which was automatically created because we ran Catkin create package. So that command is creating the structure and the manifest for us. But if you go within the source file of the package, in this case, it's empty because we haven't added any code to that package yet. Okay, so just giving you a little orientation on what Catkin create package is doing. It is creating these aptly named subfolders, and it is creating the cmake text and the package.xml manifest file, which are essential for any package. If any of these files is missing, ROS will not recognize any code which is part of source or any dependencies which are part of include. Right, so this is just a quick overview of the package itself. So let me quickly explain this issue of why do we need to source our package directory. So to do so, let me first run this command where I say echo, and I will say source the path to my Catkin workspace, and then we can say the development and setup.bash. So this is the source command, and I want to add this command to my bash rc file. Okay, so, and I'll explain in just a second what has happened. And once I've added this to my bash rc file, I can say source, and then let's just say bash rc. So what has happened is that if I show you the bash rc file, you can see at the bottom of this file, we already have this setup.bash sourced. So every time we open a terminal, it knows where ROS is installed, and that's what is allowing us to interact and navigate and find different ROS packages. So similarly, I am telling my bash instance about this new workspace, and I'm giving it the setup.bash file for this new workspace. So what that should allow me to do is navigate or interact with this newly created package in any terminal instance. So if I open a terminal instance, I should be able to say, let's say ROS CD, and followed by the name of the package, beginner tutorials. Did I spell it right? Yeah. And you can see it automatically has changed my current working directory to beginner tutorial. So just like ROS knows about the default ROS packages, because of this sourcing the setup.bash file, it now also knows about the package that you just created, right, which is called beginner tutorials. So this is why we have to source our environment, and either you can just run this command every time in your terminal session, or what I recommend is you just append your bashrc file with this setup.bash path, so that regardless of what terminal instance you launch, it will always know about the existence of the package that we created, right? So I hope that explains why you need to source your environment, as I keep calling it. This is what I mean by that. Sourcing your environment so that whenever you open a shell instance, you can actually close this previous one. And no matter which shell instance we open or terminal we open, now because it is part of my bashrc file, it will know that this is where beginner tutorial resides. So I can use things like ROSLS and what have you, the things that we covered just a while ago, to interact with my own custom package. So let's get into the weeds a little bit about this Catkin create package as well. So remember where we are right now. This is our workspace. In the workspace, we have a source subdirectory within which we created a package, and this package itself has many subdirectories as well. And so let's quickly take a look at the package.xml file, or the manifest file that we covered in the lecture. So I can open using gedit or atom or vim, whatever you prefer, doesn't really matter. And I want to open this XML file and convince you how this is something that is just created by default, right? So we didn't create this file. This was created as a result of the Catkin create package process. And so let's quickly navigate through this. The name of this manifest is the name of our package, so beginner tutorials. ROS has even sort of made a very simple description of what this package is. So this is the XML format. That's why you have tags that you have to open and close. We can, change this to whoever is responsible for maintaining this package. We can specify what kind of open source license can be used to distribute and build on this package. And you can see majority of the manifest is just commented out, and you can just uncomment things, which is the good thing about working with the with ROS itself, because we aren't supposed to write these or know how to write this ourselves, at least not at the level of a beginner's understanding. But you just need to know how to work with this file, right? So here is where all the interesting stuff is happening in the manifest.xml. And you can see we have, ROS has identified that this package needs the Catkin build tool. Therefore, this is listed as a dependency. Where did it figure out these three things? So remember, when we had run Catkin create package, we had specified 3 different packages on which the beginner tutorials would depend. And so therefore, this package.manifest has specific fields which say these are the dependencies of beginner tutorial for during the build time, and then during runtime we have other dependencies, right? So all of these again are automatically filled in, and for the most part this is all what you will find in the package.manifest. Sometimes if you have custom messages and things like that, we may find other things, but for the most part this is what package.manifest looks like. And so then let's quickly take a look at the CMake list as well. So I'll open that file, and this one would be a little bit harder to parse. Some versions, some parts of it is fine. So again, the CMake version is automatically specified, and it is supported in Kinetic and newer instances. This is the name of our package, of course, and here are our dependencies, and the required components is what is being called. And then you can see majority of the stuff is just commented out, but here is your first hint at when we make our own custom messages. So in F110 we'll have some custom messages of Ackermann steering and some specific commands that we want to send to the car. So we have to tell the build process and Catkin where those message files are located, and they are located in the message folder, or the where are the services located and where are the actions located. So we will uncomment a few of those things later, but right now you can see about 90% of this file is just commented, and that's usually the way you work with CMake lists and the package.xml. Based on the usage of your ROS package, you can choose to uncomment certain fields of this file, and that's how you maintain your package and make sure it compiles correctly with Catkin. And the main thing is to make sure all the dependencies are correctly specified. So in a nutshell, that was a quick lab session to go over a couple of points that I want you to take away. First is you should know now how to create a Catkin workspace, which we did in the very beginning. Then you should know how do we create a Catkin package and specify dependencies. And most importantly, you need to get comfortable with the hierarchy of the workspace, right? So this may sound repetitive, but it's very intentional that we have our Catkin workspace as the root folder. Inside that we have our workspace level folders, and the folder of interest where you will spend majority of your time is the source subdirectory. So inside the source subdirectory is where our packages will reside. And by the way, I haven't emphasized this, but even the workspace has its own high-level CMake, which is different from the package-level CMake, which is part of the package subdirectory, right? So don't get confused if you see another CMake outside of the package. This is meant for the workspace and not for any particular package itself. So in the source subdirectory of the workspace, where our packages reside, right now we have a empty package. But in the future we will populate it with some meaningful code. And so inside the package itself, you have its own file hierarchy. You definitely need to have these two critical files without which this package will not compile. And we have the source subdirectory where we can add some code. So these are the things I wanted you to take away from this lab session. And in addition to that, wanted to get you, introduce you and get you a feel for some of the essential ROS file tools. All right, so before concluding, I thought I'll show you one more example of this time adding some actual code to our packages and not just using these empty packages, right? So you can follow along, and what I'm going to do is the following. I'm going to first create a directory, a new directory, not a Catkin workspace. I'm just going to create a directory and call it GitHub, because I want to pull some source code from GitHub and then add it to my packages. And then let's navigate to this directory. And then I'm going to clone one of the repositories where some beginner tutorial code resides. So let me make sure I type this correctly. You can say GitHub ros1.com, and you can say link lab UVA. I believe it's called F1tenth course labs.git. Yeah, let's see if that works. Looks like it did. So don't worry, this will be posted as a handout, but you can pause and repeat this as well. So we just cloned some code from GitHub. There's a public repository called F1tenth course labs, which will keep getting updated for the different lab sessions. So yeah, so you can perhaps follow along right now. And so what we will do next is we've cloned this code, but this is right now in my GitHub directory, right? So if I just show you what we have is this folder was just cloned, and this folder has its own beginner tutorial folder. But the difference is that the beginner tutorials that we just cloned actually has a bit of more stuff, right? So the source folder is called scripts in this case, and it has a little bit of more stuff going on rather than just an empty beginner tutorial folder that we created, right? So now what I want to do is I want to copy the contents of this beginner tutorial folder from GitHub into my Catkin workspace. So I'm going to do that by saying you can copy all the contents from this path. So the path is GitHub F1tenth course labs beginner tutorials. So you copy all of the contents from this to Catkin workspace source and beginner tutorials. Right, so this is what I want to accomplish, and looks like that worked. And so then I can navigate to my Catkin workspace. So let's do that. And we should try and run Catkin make so that this code that we copied from GitHub into our actual ROS workspace is compiled. So let's run it, and looks like it ran fine. We have already sourced our file, so we don't need to source it again, but just for good measure, you can always source just your -rc. All right, so in a nutshell, what has happened is we pulled some code from Git and we copied it into our beginner tutorial. So we can in fact check ROS ls beginner tutorials. So see, it auto completes because it can find it because of our sourcing. And here we can actually check. Yeah. So now remember what's going on. This is telling me that the contents of my beginner tutorial package that I had created as an empty package has now been populated with the stuff that we copied from GitHub. So what is inside the stuff is the last part that I want to cover today. And for that, I'm going to use a better tool, which is Terminator. So let me quickly just split, and split. So now let's launch ROS core. So ROS core is running, and here I can say ROS run beginner tutorial. So again, this is a hint, right? So how is ROS run able to automatically find this beginner tutorial package? It's because we have sourced our environment. So every terminal session knows about this, and it treats it like another package, just like TurtleSim or ROS CPP and all these other examples that we saw. So if everything worked fine, I think I skipped one step. So let me, before I run it, let me actually exit ROS core as well, because here's what I think is happening. If I change directory into beginner tutorials scripts and list the contents, you can see it has a lot of these Python nodes, and each of them is like a ROS node. So I just want to to make sure first that in my root folder, all the Python nodes are executables. So that's what I'm going to do next. So we can say find name of any file which ends with .py, and I want to change the privileges to being an executable. Okay, so I know this isn't as clearly explained, but all this is doing is Linux command line speak for changing the privileges of any contents contained in the workspace which have the extension .py. So this is just so that when I run these nodes, if these files are not given executable permissions, then the node will not run, and ROS will not like that. Now we can go back to what we were trying to do. So let me relaunch ROS core. And now we can say ROS run beginner tutorials. And one of the nodes in there is called talker.python. So this node is running and it's echoing some messages, hello world, with some timestamps. And then I can run another node, which is ROS run beginner tutorials. We can say listener.python. And as you may have guessed, what is happening is our talker.python node is publishing messages on a topic, I believe, called chatter, and the listener is subscribed to that topic and is receiving messages. And so that's why I'd say I heard hello world at this particular timestamp. Then that's what the listener is echoing continuously. In fact, we can look at ROS topic echo, and the name of the topic is chatter. Oops, let me make sure I type that correct. And you can see how, the same messages are getting published on this topic, and our listener is subscribing to that. So the point of this is not to tell you how this works right now. It's in the next part of our ROS tutorials, we will learn about talker and listener, and how you set up a publisher, how you set up a subscriber, how even you set up a ROS node, and then how do you set up these topics over which these nodes can communicate. But the point of this exercise right now is only as relevant as showing you that when you add code in form of Python executables or ROS nodes using the ROSPy API, you can go and essentially repeat this workflow where you add code, you do Catkin make from the root folder. If there are no errors in the build process, then you have essentially successfully compiled some code as part of your package. And in this case, the package was called beginner tutorial. So that Git repo is public, so you can try it and be able to reproduce all of these results. And so with that, this concludes our relatively short tutorial or lab session for the ROS file system and the workspace and some ROS command line tools. I hope this was useful, and what we will pick up from is building upon this idea of listeners and talkers to get into more details of initializing ROS nodes and getting into the code part of how do you use the ROS Python API to subscribe and publish to different topics, which will become the backbone of all of the autonomous racing software stack in the future. So thanks again for following along. Do actually implement all of this and not just see the video. And then I'll see you in the next lecture and the next lab session on publishing and subscribing.